Hello everyone. So welcome to another problem solution on Thevenin's theorem. So here we are going to solve the this particular question. Find current in 40 ohm resistor like this. Now this is a playlist in which we are solving all the problems using Thevenin's theorem. But then earlier another playlist on my YouTube channel we have done on superposition theorem, and using superposition theorem also we have solved. So my idea now is to solve exactly the same problem with both superposition theorem and Thevenin's theorem. Now here if you see the second problem in that, here we are saying find current I, but here there is no load resistance. It's just a short circuited current I we need to find, and a couple of current sources are there. So this is not particularly convenient problem to address with Thevenin's theorem. This is suitable for applying and solving through superposition theorem. So we'll skip this part. Now we come to the third question in under superposition theorem. The question is exactly same. If you see this circuit, it's exactly same, and we are taking another circuit like this. Okay, the same circuit. But now we want to solve using Thevenin's theorem. Find current in 40 ohm resistance. So this is a 40 ohm resistance, and I want to find the current in this particular resistance. Now if you see, this is a procedure for superposition theorem, and finally I think the current was 0.8827. So let us see whether we'll get the same answer in this case. Okay, so let us apply Thevenin's theorem. Now how to apply Thevenin's theorem? So again, if you see, this is the second video. So I said step 1 find RTH, step 2 find VTH, and step 3 draw the Thevenin circuit and find the load current. Okay, so let me do that. So step 1 find RTH. Okay, that means Thevenin's resistance. So what is the procedure? So whatever is your load resistance, 40 ohms is our resistance of interest, right? That you remove. So once you remove this, you label these 2 points as A and B, and find the and all the voltage sources should be short circuited. So let me redraw the circuit now. So I have a 20 ohms here, then I have a 5 and 5 ohms, and this is my point A, and this is my point B. Okay. Now 40 ohms is removed here, load resistance, and here it is a short circuit, and here also it is a short circuit. Okay. So in other words, even these 2 points are actually equal to B, because what this same point is short circuit, there is no voltage drop anything here. So these 2 points are also B. Okay. So in other words, if I redraw this circuit, so this is equivalent to having a circuit like this. So there is a point B. From B to A there are 2 paths here, right? So let me draw those 2 paths, and then again these 2 will join to A. This is 5 ohms and this is 5 ohms. Meanwhile from B to B there is a 20 ohm resistance. Okay, so something like this. Now because this B point is same, and then this 20 ohm resistance is anyway forming a loop, it's getting itself short circuited, so this part is actually irrelevant. Okay, so it may be 20 ohms, it may be 200 ohms, it may be 2 ohms, or whatever, it may be even 0 ohms. It's actually irrelevant because both sides are anyway short circuited. In other words, if I say the circuit can be considered like this, it is 3 parallel paths. Okay, so one parallel path is direct short circuit, another parallel path is 20 ohms resistance, and another parallel path is having 5 ohms and 5 ohms. So here we have point A, and here we have point B. Okay. So here it's basically these 2 are same. Okay, so this is also point B. So here this 20 becomes irrelevant. Okay, now we have AB parallel of 2 5 to 5. Okay, so RTH is nothing but 5 parallel 5. Okay, so that will be 2.5. 2 equal resistances connected in parallel, the effective resistance will be half of it. Okay, so RTH we found out, that is the step 1. Okay. So now go to step 2. Okay, so let me do it here. Step 2. Find Thevenin's voltage VTH. Okay, so how to find Thevenin's voltage? We introduce the resistances back into the picture. The voltage sources back into the picture. So I have a 60 volts here, 60. Then I have what was that? 15 volts. Okay, so I have a 15 volts here. and then I have two paths. Okay, so one path is 20 ohms, another path is 5 ohms, and these 2 points are my AB points. Okay, so VAB is how much? Okay. So this is effectively the question. So now if you note, the potential at this point is plus 60 if you consider B as a ground, and similarly the potential at this point is plus 15. So the potential difference between these 2 points is actually 45, and the current resistance between these two, this is one path above and one path below. So we don't care about the above path because that is anyway independent. So let us now find the current in this particular branch. Okay, so what is the current in this branch? The current in this branch is nothing but 10 ohms. Okay, total resistance is 10 ohms, total voltage is 45 ohms. So the current here is 4.5 amperes. Okay, so simple. So for example, I1 equal to 4.5. How do I get this I1? See, or let's say I1 is unknown. So you apply the Kirchhoff voltage law across all these points. Okay, so I start at this point, apply the Kirchhoff voltage law up to here. So when I apply Kirchhoff's voltage law, so I'll get I1 multiplied by 5. So here my voltage is going down, so it is minus sign, plus one more 5. So this is the total voltage drop. Then here further I reduce by 15, so minus 15, and then I increase by 60, plus 60 equal to 0. Okay, so from this one unknown one equation, so I can find I1. Okay, so what is I1 here? So that is nothing but minus 45 divided by minus 10, or 4.5 amperes. So that is exactly what I have written here. See, this kind of thing, after getting some experience, you don't have to write all these equations and anything. With just observation you can write it. Now how to find VAB? So VAB, simply apply Kirchhoff voltage law KVL from B to A. So I start at B. Okay, so I go left, I increase 60 volts. Okay, so VAB is equal to plus 60. Okay, so I reach at this point. Then I am going in the same direction of the current. So this point is higher potential, this point is lower potential. My voltage is dropping. So 4.5 amperes into 5. Okay, so minus 4.5 into 5. So this will give me the VAB. Okay, so what is that? So 4.5 into 5, that is 22.5. Okay, so 60 minus 22.5, so I'll get 37.5 volts. Okay, so this 37.5 volts is actually my Thevenin's voltage. Okay, so equal to VTH. So now step 3. So here we draw the Thevenin circuit. So the Thevenin circuit is simple. It will have a voltage source in series with, so this is my AB points, and this is 2.5 ohms that we got, 2.5 ohms, and this is 37.5 volts. Okay, so this is my Thevenin's source. So 37.5 volts in series with 2.5 ohms. Now what is the load resistance? So here if you see, the 40 ohms is the load resistance. So let me connect back the 40 ohms load resistance now. So now what is the current in the 40 load resistance IL? So IL is nothing but VTH divided by RTH plus RL. So that is nothing but 37.5 divided by 2.5 plus 40. Okay, so that is 37.5 by 42.5. So 0.8823 amperes. Okay. So this is the final load current in the 40 ohms resistance. Okay, let us compare this answer with our answer that we got in the case of superposition theorem. Okay, so there it was the third problem. So here you can see superposition theorem, and then we got all these things. So finally the answer is 0.8827. Okay, so, and here I am getting 0.8823. So more or less this is, in fact this seems to be more accurate, and here it has some kind of rounding of error. Okay, so this is the final answer. Both answers are matching. You now choose whether you feel the superposition theorem is easy or Thevenin's theorem is easy. So for me, Thevenin's theorem is easy, but I learned both the theorems. So this is superposition theorem and this is Thevenin's theorem. Both answers are same. Okay. So I hope you are liking this video. This is the second video on Thevenin's theorem, and I will be solving few more problems using Thevenin's theorem and compare the solutions with that of superposition theorem. So if you like this video, please press the like button, and you can subscribe to my channel and refer this to your friends. See you in the next video with one more problem on Thevenin's theorem. Thank you.